Good day, math learners. In this video, we will be talking on the coordinate proof. In coordinate geometry, real numbers and ordered pairs are associated with points. In proving geometric theorems using coordinates, the first step is to locate the plane figure relative to the coordinate system. It simplifies the algebraic operations involved in writing the proof. For example number 1, draw a triangle with vertices N, B, and C and show that it is isosceles. So we are going to plot the given points. Point N with the coordinates -1 and 4. Point B with the coordinates 0 and 1. And point C with the coordinates 2 and 5. And when we connect these 3 points, it forms a triangle. But we are asked to show that this figure is isosceles. Take note, class, that a triangle is isosceles if at least 2 of its sides are congruent. Now, how can we prove that this figure is an isosceles triangle? In order to prove that this is an isosceles triangle, we are going to use the distance formula, which is p sub 1, p sub 2 is equal to square root of quantity of x sub 2 minus x sub 1 raised to 2 plus the quantity of y sub 2 minus y sub 1 raised to 2. We are going to get the distance from point N to point B, or the length of line segment NB. So our equation will become line segment NB is equal to square root of -1 minus 0, because these are the values of our x coordinates of points N and B. Then copy raised to 2 plus 4 minus 1, because these are the values of our y coordinates of points N and B. Then copy raised to 2 from the formula, and then simplify them further. -1 minus 0, the answer would be -1. 4 minus 1, the answer would be 3. And our equation will become line segment NB is equal to square root of -1 squared plus 3 squared. And -1 squared, the answer is 1, and 3 squared, the answer is 9. And simplify them further, and line segment NB is equal to square root of 10 units. So from point N to point B, its distance is square root of 10 units. To get the distance from point N to point C, or the length of line segment NC, we still use the distance formula. So our solution will become line segment NC is equal to square root of -1 minus 2, because we substitute the values of our x coordinates of points N and C, then copy raised to 2 plus substitute the values of y coordinates of points N and C, which are 4 and 5. So we have 4 minus 5, then copy raised to 2 from the formula, and then simplify. -1 minus 2, the answer is -3. 4 minus 5, the answer is -1. So our solution will become line segment NC is equal to square root of -3 squared plus -1 squared. Then simplify. -3 squared, the answer is 9. -1 squared, the answer is 1. So the line segment NC is equal to square root of 10 units, or from point N to point C, its distance is square root of 10 units, and the length of line segment NC is equal to square root of 10 units. So this time, we will get the distance from point B to point C, or the length of line segment BC. We still use the distance formula, so our solution will become line segment BC is equal to square root of 0 minus 2, because we substitute the values of our x coordinates of points B and C, then copy raised to 2 plus substitute the values of y coordinates of points B and C, which are 1 and 5. So we have 1 minus 5, then copy raised to 2 from the formula, and then simplify. So 0 minus 2, the answer is negative 2. 1 minus 5, the answer is negative 4. So our solution will become line segment BC is equal to square root of negative 2 squared plus negative 4 squared. Then simplify. Negative 2 squared, the answer is 4. Negative 4 squared, the answer is 16. And then add, and the answer would be square root of 20. So this time we are going to get the factors of square root of 20, which is square root of 4 and square root of 5. So get the answer, the square root of 4 is equal to 2, and copy square root of 5. So line segment BC is equal to 2 square root of 5 units, or the distance from point B to point C is equal to 2 square root of 5 units. Since two of its sides, line segment NB and line segment NC, are congruent, then triangle NBC is isosceles. For example number 2, find the fourth vertex of a rectangle when 3 vertices are given. So we are going to plot the points A, B, and C with the corresponding coordinates. For point A, we have negative 3 and 1. For point B, we have negative 2 and negative 1. For point C, we have 2 and 1. And then we connect the points accordingly. This time, we cannot plot point D because its coordinates are unknown. How are we going to get the coordinates of point D, which is considered as the fourth vertex of this figure, to form a rectangle? When we were in grade 9 level, we studied that the opposite side of the rectangle is considered as parallel. So we assume that the line segment AB, which is here, is parallel to its opposite side, which is our line segment, CD. These two segments have the same slope because according to its concept that if the lines are parallel, then they have the same value of slope. So to get the slope of line segment DC, we have to consider the slope of our line segment AB and consider this formula: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then after that, substitute the y coordinates of points A and B, which are negative 1 and 1, and of x coordinates of points A and B, which are negative 2 and negative 3. So it is equal to negative 1 minus 1 over negative 2 minus negative 3. And then negative 1 minus 1, it is equal to negative 2. Negative 2 minus negative 3, it is equal to 1. Simplify it further, and the answer is negative 2. After that, get the equation of line segment DC with point 2 and 1 and the slope negative 2 using the point slope form. And the point slope form is y minus y sub 1 is equal to m times x minus x sub 1. So we are going to substitute the variables y sub 1, m, and x sub 1. For y sub 1, it is equal to 1. For x sub 1, it is equal to 2. And for m, or the slope, it is equal to negative 2. So our equation will become y minus 1 is equal to negative 2 times the quantity of x minus 2. After that, simplify this equation using the distributive property. So negative 2 times x, the answer is negative 2x. And negative 2 times negative 2, the answer is positive 4. So our equation will become y minus 1 is equal to negative 2x plus 4. And then transpose negative 2x to the left side of the equation, and it will become y plus 2x. Transpose negative 1 to the other side of the equation, and it will become 4 plus 1. And then make it in a standard form. We have 2x plus y is equal to 5 as our equation 1. So again, we consider that the opposite sides of the rectangle are parallel. So we assume that the line segment BC, which is this one, is parallel to opposite side, which is the line segment AD. These two segments have the same slope because according to its concept that if the lines are parallel, then they have the same value of slope. So to get the slope of line segment AD, we will get the slope of line segment BC with this formula: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then substitute the y coordinates of points B and C, which are negative 1 and 1, and the x coordinates, which are negative 2 and 2. So it is equal to negative 1 minus 1 over negative 2 minus 2. So negative 1 minus 1, the answer is negative 2. Negative 2 minus 2, the answer is negative 4. So get its simplified form, and the answer is 1/2. After that, get the equation of line segment AD with point negative 3 and 1, which is this one, and the slope 1/2 using the point slope form. So according to the point slope form, we have y minus y sub 1 is equal to m times the quantity of x minus x sub 1. Please take note that we have to consider this point slope form, and the value of our y sub 1 is 1. The value of our m is 1/2. And the value of our x sub 1 is negative 3. So our equation will become y minus 1 is equal to 1/2 times the quantity of x minus negative 3. After that, we are going to multiply 2 so that our fraction form will be eliminated. So 2 times y, the answer is 2y. 2 times negative 1, the answer is 2. 2 times 1/2, the answer is 1. So it will become x minus negative 3 or x plus 3. And then transpose x to the other side of the equation, and it will become 2y minus x. Transpose negative 2 to the right side of the equation, and it will become 3 plus 2. And then simplify further, you will be getting negative x plus 2y is equal to 5 as our equation number 2. Solve for x and y using equations 1 and 2. 2x plus y is equal to 5 as our equation 1, and negative x plus 2y is equal to 5 as our equation 2. Now, we are going to multiply both sides of the equations by 2 in our equation number 2. And our equation will become negative 2x plus 4y equals 10. This process is what we call the elimination method, in which one of the variables will be eliminated and the other one will remain. So, this time, we can now eliminate the variable x because 2x plus negative 2x, the answer is 0. Y plus 4y, the answer is 5y. 5 plus 10, the answer is 15. Now, we are going to divide both sides of the equation by 5 so that y will be isolated. So 5y divided by 5, the answer is 1y or y. 15 divided by 5, the answer is 3. So our y is equal to 3. To solve for x, use the equation 1. 2x plus y is equal to 5. Next, substitute our y with 3. So we have 2x plus 3 is equal to 5, and then 3 should be transposed to the other side of the equation, and the equation will become 2x is equal to 5 minus 3. Simplify 5 minus 3, the answer is 2. Then we have to look for the value of x, so we need to isolate it. So divide both sides of the equation by 2. 2x divided by 2, the answer is 1x or x. And 2 divided by 2, the answer is 1. So our x is equal to 1. And the solution set is 1 and 3. Or the coordinates of point D are 1 and 3, which is the fourth vertex of our rectangle. So now we can plot the point D with the coordinates that we have solved earlier to form a rectangle. Thank you for listening, math learners.